All right, I am Boyd Hemphill. You can find me on Twitter at @bhempi. Mike Rabb, VP of Customer Success. He is our @stackengine. All right, a little bit about me. First, I was an Oracle developer. Then I was a MySQL DBA. Then I was a PHP application developer. I actually wrote an MVC framework in PHP. Yes, you can make fun of me for that. I like it. All right. Then I was a system architect. How that happened, don't ask. I don't know. Then I was a DevOps director. Again, you may laugh. And the funniest thing of all, I am now an evangelist. I think of myself as, well, Stack Engine Jesus. Yeah, that's me. All right. I started Austin DevOps in 2012. We've grown that to nearly 750 people now. It's amazing. Come out and see us. Got involved. I'm a co-organizer of DevOps Days Austin with Karthik back there. I ride on their coattails. Those guys are amazing. They didn't really need me. They were just nice enough to give me a cool shirt. I became involved in Docker Austin here in August as I got involved with as I moved to Stack Engine. And I'm, as I mentioned, working on the first container days in Austin for right now. We're targeting late February. So keep your eyes out for that, all right? A little bit about Stack Engine. We got started in May of 2014 to address the challenges facing Docker adopters in production. That was, yeah. All right. We made our funding announcement in October. We have $1 million behind us right now, although I think we've spent some of that since October. We're currently in private beta, so there is a velvet rope you have to cross, and Mike Rabb, our VP of Customer Success, he is a scary guy that you have to convince to let you in. You are all the cool kids because you live in Austin, so just give him an email, let him know what you're doing, we'll get you there. All right, so with that, let's set some common ground. All right, what is the goal? And if you've been to Austin DevOps, you're not allowed to answer. What's the goal of your company? Anyone? Bueller?
Be efficient. To run Docker.
The goal of your company is to make money. Everything that you do should be couched in the process, in the thought of, how does this make us money? Because the code and Docker don't sign your paycheck. Your company does. All right, so think about that for a little bit while I pontificate on DevOps. All right, what is DevOps? Is DevOps a process? We hear that a lot. Is it this sort of overlapping set of concerns? Woohoo, dev and ops and QA and... Is it culture? Yeah, you hear that one a lot. No, DevOps is a philosophy, and in my opinion, the definition there is the way a technology organization embeds itself in a business to the benefit of that business. So what does that mean, all right? Well, that means that the other things that we just talked about and a whole lot more are really models of that philosophy that we then go and implement, typically with technology, right? Those are our tools. But Docker transcends that. Docker isn't something that a kick-ass DevOps guy or a kick-ass developer can goes and does this one cool thing with. Docker changes the entire game the same way the public cloud did, in my opinion. That's why I decided to leave a really cool job and take this one. All right, so what does an ideal containerized application look like? Well, of course, you have the unicorn, and that is Netflix. It's service-oriented. You got all these microservices. You have this thing that rates movies based on what people say, and they can flip 150 machines on and deploy it, and then start trickling traffic over, and they got Chaos Monkey and all that stuff. Yay, right? Okay. Service-oriented architecture. I think we've all got that in our heads. But what are its benefits? Why would your company want to go and adopt that? I mean, how is that going to make you money, you being your company? Well, one thing it's going to do is it's going to increase feature velocity. All right? Because you can write things and you can crumple them up and throw them away fast, you can take more risks. You can innovate faster. And when you can innovate faster, you get things done faster. Of course, there's the operational aspect of it that everybody talks about. You get more density. I love it that everybody talks about, yeah, you'll save money. You know, you can use 80% of your machine instead of just 10% of your machine. I want you to think about that in the context of Black Friday, which wasn't too long ago. Okay? How many of us sit around knowing that our web servers are only running at 10% CPU or whatever, right? Whatever that 10% number they throw around means. And that's our cushion. Well, if we achieve density, suddenly we don't have a cushion anymore. Or we need to develop some other way of creating a cushion so that when we get unexpected spikes in load, they are handled for us and our beepers aren't going off. Well, our beepers. How old am I? Who carries a beeper? All right, your cell phone. Yeah. All right. Separation of concerns. This one really excites me. If you're a developer, you've always heard code to the interface. Rarely do we ever do it, but you code to the interface. What Docker does, what containerization does, is it moves that interface out to the infrastructure level. And what this has a really, really profound effect on how you can arrange development teams. Imagine for just a moment that you've got a team of 50 and they're all working on a thing. Now imagine that you've broken that thing up into 20 different concerns, 20 different microservices. You can take a team of 3 people and dedicate them to a microservice. If you can guarantee the interface to that microservice, that when I hit it this way, it behaves that way, then if that thing's written in PHP and it's poor performing, and you've got a guy going, if we just rewrote this thing in Scala, it would be all better. They can go rewrite it in Scala, because as long as it honors the interface, it doesn't matter. That's what it means to move that interface out to the infrastructure level. So, one, it gives you more stability, because as long as people are honoring their interfaces, your stuff just works. That's Netflix. But the other thing it allows you to do is this. Features in each of those microservices can move at the pace that that microservice needs to move. It doesn't need to wait on anything else. You don't have the mythical man-month problem of 50 people all trying to communicate in a combinatoric mess. You have 3 people who are communicating, and they need only communicate with another team when they are going to make a breaking change that affects another team. This is efficiency. And when you take all of these things together, what you're doing is you're creating a lasting competitive advantage for your company. If you're Target, you're going to kick Walmart's ass if you can do this and they can't. You're going to be able to get features to market faster. Your web portal, your technology gizmo, your supply chain management tool, all of those things are going to be better, faster, stronger. You're going to win, at least for a while, until your competitors catch up. But at the rate of things are going today, there'll be some other maddeningly crazy technology that'll do it all for us. But what is Docker's reality today? This is still very early days for Docker. All right? Yes, they're in production, and they've been in production since what? February? Ooh. Yeah, what does that mean? That means they say they're production ready. Yeah, take a risk with our shit. Yeah, your shit will work. Yeah. They're not the ones that get the phone call in the middle of the night. They're not the ones on the phone with the VP going, yes, sir, sorry, sir, sir, yes, sir. Nope. So they say it's production. Do you say it's production? What do you say?
Hell yeah.
It's even earlier for Rocket. If you missed that announcement, CoreOS just announced that they're going to have their own containers. And it's rather interesting. It really validates the market. Tools to support containerized applications are immature, or they simply do not yet exist. And that, interestingly enough, I think is some of the stuff that Ollie will be talking about, because Docker has announced a whole fleet, pun intended, of tools to address some of these issues. Service-oriented architecture is hard. Rarely will you meet a developer who understands code to the interface. They can do it, sort of. But do they understand it? Do they understand why they're doing it? Do they understand why they took those extra 15 minutes to write the interface and ensure the interface? Probably not. Increasing developer throughput is only a local optimum. All right, so that guy that, what's the goal of your company? To make money? Okay, a local optima is a false economy. So I wrote a blog called Laundry Ops. Basically, it goes like this. Do a load of laundry a week instead of waiting until the weekend to do all your laundry. What's going to happen? Well, your loads are going to get smaller. But, okay, that's kind of obvious. What's going to happen to your closet? It's going to be full of clothes. Now, stop and think for just a second that instead of you seeing clothes in your closet, picture all the price tags. That's a lot of freaking money, isn't it? Even for a bunch of people like us, a bunch of neckbeard operators who are all jeans and t-shirts most of the time, that's still a lot of money. These things cost a lot. And that is cash that is locked up in your closet that you could be buying the latest Civ game. What is it? Beyond Earth now? Woohoo! Or you could be driving a cooler car. You could be going to DockerCon Europe. It's an opportunity cost for you to store that in your closet. The same thing is true with features in your code repository. If developers can go faster, they're just stuffing things into Git. But how are they getting into production? You know why it's called production? Because it produces money. So if those things are going into production, they make money. But when they sit in Git, the $80,000 or $90,000 of salary it took to produce a thing isn't making you any money. You lose. Your company is losing while those things are sitting there. That's the central premise of continuous delivery. Okay, so and if you haven't read Jez Humble's Continuous Delivery, I strongly recommend it. So we'll post these slides. You can go check out Laundry Ops. It's a short article. It's on stackengine.com. All right. So what is the software delivery cycle all about? Developers are moving forward with Docker. This is the most common uptake we've seen. We've talked to over 60 companies now, and by far the majority of them are adopting Docker through the developers. The developers are looking for better ways to do their job. QA is seeing this and they're going, wow, imagine the test grid that we could do. Imagine how disposable that is. Instead of waiting for minutes for a machine to come up, I got seconds for these containers to come up, and I can just sort of leave the machines around and things happen faster. That means a shorter feedback loop. That means shorter times to production. That means better feedback to the developers quicker. Build engineers are seeing paralyzed builds for the same reasons, right? So they may not believe in the moon landing, but they're adopting this faster than operations. And then the operations guys, they panic. All right? There's no tools, there's no instrumentation. We can run these things, sure, but what are they doing? How do we know they're performing? If something goes wrong, how do I reason about it? How do I fix it? What's telling me it went wrong and why? And God help me, we don't want to piss that guy off. I mean, all right, so information architecture. What we're going to do here in the rest of this is I'm going to give you a problem description. I'm going to talk about how stackengine is working on that now. I'm going to talk a little bit about how stackengine is working on that for the future. All right, problem number one, we dubbed the final mile. What does this mean? Well, your developer creates an image. That image is handed off to QA. QA tests the image. The image goes through some sort of build system, comes out and lands in a private Docker registry. Yay. How does it get into your production topology? Physical production topology, right? How does that container go to a place? That problem hasn't yet been solved. And we've actually got a pretty good manual solution right now. All right. So the developer uses the container, yada, yada. This is where I don't have my clicker. All right. We build a manual solution. Huzzah! That's going to work out well, right? Yeah. Hey, don't let go. All right. Then someone comes along. We're thinking of ourselves like this. And we try and build a better solution. Something that's going to work for everybody most of the time. All right. So how do we cross the final mile? Well, for us, what we do is we create a component called a registry. So in my example here, you can see that I've created something called Quay.io. If you're not sure, it's really supposed to be said key. But if you're not familiar with this, it's a private Docker registry as a service. Okay? So you can go to Key, you can get your own private Docker registry. I've created that. And I've put something in there called LazyBox, which is really just BusyBox, and I just renamed it just for the example. You pick a few hosts in your mesh, and we've tested our mesh to nearly 1,000 machines. So you pick a few of those. I tell it that I want 2 lazy boxes on each. Magic happens. Okay, so what's the magic? Well, you're communicating with just one of the machines in the mesh, usually the leader. And what's happening is it's sending through RPCs, remote procedure calls, to all of the machines in the mesh that you've chosen. Hey, start up, do whatever it is that the command that we're talking about. In this case, run a lazy box. And poof, containers happen. Now, that looks broken because they're not started. Why are they not started? I didn't give them a command to run, right? I didn't give them some infinite loop to keep them going. So what happened was the container came up. I don't have anything to do, and went away. All right. So what does this look like in the future? We need to support other container types, the obvious one being Rocket at this point. We need to do policy-based deployment. In other words, just like your build system right now is watching GitHub or your Git repo, wherever it is, and when it sees a new push to a particular branch, it takes an action on that, creates an artifact, does a thing. We want to be able to watch your Docker repository, whether that's a key, whether that's a private one, whether that's the Docker Hub. And we want to be able to say, oh, look, you have a new version of foo. Well, we know that you want 7 foos and you want them in 3 data centers, and you want at least one of those data centers to not be on the same continents as the other. And we're going to release that for you in some reasonable way that you can expect. That's what we mean by policy-based deployment. Okay. And when we can achieve that, we have sysadmin nirvana, fluffy bunnies, and rainbows. All right, so this leads to the next problem of container sprawl. So to define that, first there was VMware. And suddenly, instead of having 2 weeks, some guy going, yeah, man, I need a thing. Okay, you can have that in 2 weeks. And somebody ordering it coming in, then racking it and cabling it, all that great stuff, right? Suddenly, I could try an idea. So you'd have a developer spin up a thing. They'd spin up the thing, and then they'd walk away from it. They'd spin up another thing, and they'd walk away from it. And a few weeks later, you've got dozens of these VM things running around. And VMware loves this. You're paying them money for each of those. Yay. Rackspace loves this. You're paying them money for each of these things. Yay. And you know what? As a sysadmin, who here has ever got fired for not turning something off? And who here looks at the kill switch, terminate that instance, and goes, no fucking way. Right? Brian used to work for me at W2O, and I would say kill an instance, and he'd just look at me. And I'd say, which one is it? I'll go do it. Okay? Brian's a smart administrator. All right, so you have this sprawl of VMs everywhere. And then the public cloud came along. So the developer didn't even need to go to somebody who had control of VMware. They just took their credit card and, damn it, we pay those guys pretty well so they could do this, right? And they go to Amazon, they use a free tier, they spend $20, and they get their idea going. And they go to their BA buddy and they'd say, hey, BA buddy, look at this little solution thing I wrote for you. Isn't it cool? And the BA buddy'd go, yeah. Clickety, clickety, click. It'd be cool if it did this. Okay, here you go. It'd be cool if it did this. Okay, here you go. And then BA buddy, not saying anything to anybody else, goes and shows his BA peers. Well, what's happening here? Suddenly you have this bandit system running around. And it goes down after, 70 BAs are now using it. And so operations gets called. Hey, the thing is down. What thing? You know the thing. What thing? The thing all the BAs are using. Is this a crank call? Prince Albert in a can is not here. All right, so this happens, right? Okay. So we all know how that ends, and then suddenly it has to be adopted. We have even more VMs. Okay, and this is where the phrase cattle not pets started, right? Don't name your servers, yada, yada, yada. Docker takes that even a step farther. At this point, we're not talking about cattle not pets. We're talking about ants, not cattle. We don't even care if they're alive anymore because others should have started or been hatched by a queen somewhere. All right, Rocket potentially segments this market. Now that's validating, right? But so your concerns just doubled. And then if you throw an LXC, really it becomes combinatoric, and it becomes combinatoric really, really fast. So you've got all the different security profiles, all the different performance metrics, and so forth and so on of all these containers. Somebody needs to give us some sanity here. So we need to be able to schedule these things. And Docker mentions this a lot. I love it. It's the bin packing problem. If you're a computer science grad, you've had to deal with the bin packing problem. There's all kinds of white papers on it. You should look it up. It's really, really cool. So first there were containers and Docker files and images, and those are on your VMs. And then the VMs are on physical hardware located in an availability zone somewhere. And then the availability zone's in a data center in a geographic region somewhere. And those dimensions of the bin are only the physical ones. What about memory availability, CPU, I/O weight, right? The actual aspects of the machine the thing is going to go on. And if you're on a VM, what about the actual underlying hardware? We all know that I/O weight is a terrible, terrible thing in the cloud, right? So we have to worry about all of those things when we want to schedule something intelligently. And that makes my head hurt. I'm just not smart like Adrian Cockcroft. I want to be. Okay, so we need some artifact inventory. We need to know where our stuff is. So where's my stuff? Today, we can show you where your hosts are. We can show you the basic health of those hosts in terms of CPU and memory. We can show you where your images are, what hosts they live on, and we don't need to actually go to your repository or the Docker Hub. Once you have that image somewhere in the mesh, you can simply click on it, start it on any other machine in the mesh, and it moves across that network instead of the public network, which is generally a lot faster for everybody concerned. We can show you where your containers are, and we can let you do things to your containers. Start them, stop them, group them up, search for them, and so forth and so on. We can filter them, we can build them, we can do all kinds of fun things. And finally, if you just want to search for stuff and you don't know what it is, you just know it has some letters in it, we can find that for you too. In other words, when you have all these ants running around, we can help you locate the ant you're potentially looking for. But what about the future? Right now we need a more geographically aware physical topology. What do I mean by all those fancy schmancy words? Basically, you know you want to deal with something in Spain, you should be able to start in Spain and drill down intelligently to where you want to be, all the way down to the image in the container that it was spawned to, okay, or the container in the image that spawned it. So that's one of our visions for where we'd be going in the future. Again, policy-based inventory levels. If you want to have so many so many containers on a particular machine, you should be able to set that, walk away, and let the stack engine controller handle that for you. Okay, there's just too many things for you to go, I want one of these here and two of these there. Because in today's reality, if you're dealing with 200 or 300 machines, and each of those has just 10 containers on it, you're dealing with thousands of things. And you can't log into them. They're containers, not machines. They don't feel like the machine that you're used to. You need a different way of, a different paradigm. And when we can achieve that, more fluffy bunnies and rainbows. So telemetry. Beyond the physical dimensions of, where is my thing geographically, we need to know, what does monitoring look like in an application? Funny story. Back in alpha, I was testing our controller, and I had shrunk an image. The image went from 900 megabytes to 18 megabytes, like a 50x shrink, right? So I started these images on the same machine. I started these images as containers on the same machine, and they were using half as much CPU and half as much memory according to the controller. So naturally, I thought, that's a bug. And I went looking. Well, it turns out it wasn't. I went all the way down to the file system into proc, looked at the actual containers metrics, and sure enough, it was right. The controller was telling me, hey, because you took this action, in this case, good side effects happen. When's that ever happen? But I'm still suspect. But there's a blog post about that, about how the controller did that, and all the digging that went into it, if you'd like to know more about the guts of Docker. We don't want to get into the business of log aggregation. We don't want to compete with the Logleys and Splunks of the world. Those guys are kick-ass at what they do, and that's its own big problem. But again, there's a nice blog post out there using Jeff Lindsay's logspout container, right? You start logspout, every container you start after that, if you've got 12-factor logs, i.e. if everything's being written as standard out, it just picks those up and shoves them right into syslog for you, or wherever else you want to put it. So for me, I shove it into syslog, I went and got a quick paper trail account, and an hour later, poof, log aggregation. An hour later, log aggregation. Is that mind-boggling or what? All right, so, and it's been quite useful. Could it be better? Yes. So, decision dimensions. We need host-level metrics. We need to know, so here you go right now. How many of the things do I have? That's our dashboard. What are my hosts doing? All right, are they stuck? So right now we have CPU and memory usage. We need I/O weight. We need a few other things. Pardon me. Is it doing what it's expected to do? In other words, can I drill into a thing and see more details about it? What is it, and what are the actual parameters that are going on here? You can see that there are all sorts of environment variables set here. If the application isn't behaving like it is, I can see that right there. What are these images made of? What is each layer? In other words, what does the Docker file essentially look like? What does that look like as a graph? Picture's worth 1,000 words. That might just tell me where I want to be a little bit faster. There can never be too much information. So we need to improve our host metrics. We need more. We need to improve our image metrics, mostly around size. It's pretty easy to kill a host just by downloading a bunch of images. They get pretty big and pretty bad, even though you have AUFS and all that going on. We need to add container metrics. Right now, we have stuff about your hosts. And when we get there, again, more fluffy bunnies and rainbows for everybody, because we'll be able to make intelligent decisions about scheduling things onto your host topology. Problem number 4, the lack of a centralized control plane is a really, really big deal. The ability to act upon a system from a single point of entry. Okay, so I log into one place. The actions should happen next to the information that caused the action. In other words, I don't want to go over here and see this container stop and have to go 3 screens and 5 clicks over and fix that. Okay? I don't want to query an API endpoint and then have to think of a whole nother API endpoint. I should have a locality of information if you want the information architecture work for that. Action should happen within the context of an inventory, okay? So I should be able to say, I have this group of things, and I want all of those things to behave in that way. So I should know what my inventory levels are, and I should be able to manage those inventory levels. And all of these should be able to happen through the UI, which you'll see, an API, which we have and is currently undocumented. Sorry, I'll get to it. And a command line interface for those of us, like me, who still like to sit at the big black blinky screen and feel really cool about myself. All right. So, what actions can you create? What actions can you take today? You can do all sorts of things with your image. We can manage images like crazy. You can push tags, you can pull tags, you can do all kinds of stuff. From there, you can start and stop containers, you can pause them. What about actions in the future? We need to be able to initialize things. Right now, like I showed you earlier, we can do that from a repository. We can do that from any image that's on there. But we're missing, say, a Docker file, right? All right, so there's some things we need to do. We need a taxonomy. We need to be able to provide you with the ability to create a taxonomy of your inventory, because yours is going to look different from somebody else's. And we need to be able to take corrective actions. So, policy-based actions by the controller. In other words, go do this. And when something goes wrong, do this, do this, do this. And if it goes wrong again, then call me, email me, throw an alert, whatever. We need a control plane taxonomy. That basically will look like a key value tagging, right? These hosts have served this purpose for this customer doing these things. And again, ants, not cattle. And when we get there, more fluffy bunnies and rainbows. Finally, we have heterogeneous service providers. Containers live on services. In other words, containers have to live somewhere. They live on a machine. They live on a VM. They can live in a POS, if you want a higher abstraction. They come from different places. They can come from the Docker Hub. They can come from Quay.io. They can come from a Docker file. I mean, if you can put a Docker file on a machine running Docker, you can create a container. Within an IaaS provider, take Rackspace for instance, they have cloud database, they have load balancer services, all of these things. Those are not containers, but they are abstractions like a container is. And we need to be able to, if your control plane is really going to control all the things, we need to give you control of those. You need to be able to manage those the same way you're managing everything else. Persistent data stores present their own unique services. How many of you have ever waved your hands about, oh, look, all the microservices? Yeah, Netflix is a micro data organization, right? How often do they talk about that big, nasty Cassandra ring that they actually have? The one that they buried and now they have something else they because they had to rewrite it? What they MASH or something like that. I don't remember. So, hand waving, right? The minimum we should be able to do is provide you a link to your RDS, your Redshift, what have you. So, components today. As you saw earlier, you can build stuff. So we need to know where your stuff is coming from. A Docker registry, Quay.io, that sort of thing. So right now, we abstract a registry away. Once you have those, you can create Docker components that are coming out of those things. All right, fantastic. So you can create an Nginx, you can create a this, you can create a that. You can create myapp.1, myapp.2. And you can see we have AWS and VMware there, but those are just coming soon. We know we need those, so we put those there as placeholders. So in this case, I have a MySQL container. I'm going to go and I'm going to start it. Then I have a web server, and then I have an application server. And then I'm going to run the cache. And you notice that in some cases I'm running more than one of these on more than one host. Now, I have a fully working application, right? I have a database, I have web servers, I have application servers, maybe that's PHP, FPM. I have Redis for my caching layer. Okay, I can run a website this way. It could all work. It could all work on one machine. That's kind of cool because a developer could do that. And yet all the pieces are still separate for all the networking concerns, integration testing. All right, so for the future, I love this picture, we need component types that are more varied like Lego bricks. In fact, we need to acknowledge the fact that there are Lego bricks and there are techniques. You know, those beams with the pins and all that stuff, that's Lego too, and they actually work together. I know that sounds crazy if you've never tried it, but they do, trust me. I coach robotics, I know this. And this is actually a picture of something I did at Lego Fest in Dallas this year. That's a 3-foot by 3-foot pyramid. That's an open source Lego project. I sat down, and by the time I had the first 2 layers done, I had kids coming up saying, "What you doing?" And I would explain it to them, or this little girl right here decided that she was the boss, and she would tell everybody what to do. And she did a damn fine job of it, and an open source project needs that. And by the time we were done, we had a couple hundred people actually surrounding us, taking pictures, including parents and all that, the Lego people and so forth and so on. And we had a pyramid, I calculated, that was over 12,000 bricks, all put together from the same components, but turned into a pyramid. It's amazing what you can do with just a few things of a similar kind. We know that we have a much more heterogeneous environment. We're going to need to deal with that. And we built this giant pyramid. We did it in under 5 hours. And when you can do that, you get pyramids or you get fluffy bunnies and rainbows. All right, so what's our roadmap look like? Problem number 6 is service discovery. I am hoping that Andy Shin and or Jeff Lindsay will come and talk about service discovery early next year. That would be super awesome. All right. What does service discovery do? It allows multiple deployments of the same service on a host. In other words, things can find where they should go. They can find where other things are. So I can run 2 Redises on the same machine and not have them run into each other on the port, because when the when the second one sees that there's already a Redis there, it can automatically switch its port. That's pretty sexy. Service discovery gives you that. Containers register themselves on startup. Okay? I bring up a MySQL container, and it says, I am a MySQL container. And then when the web server comes up, it says, I need a MySQL container. And it's already right there in the service registry, and it makes the connection without any manual intervention. That's pretty sexy. We favor something like Console in our research. Okay? Console is really slick. And Console has all the checks and health checks and stuff like that. So we're looking at Console as sort of the way we want to do things. And when we were at Chef Summit, somebody said, hey, why can't the Chef server act like Console, but still have the same cool Chef search interface? So we're actually thinking to ourselves, that would be really awesome if you could search with the same machine syntax that most people are already used to. That would be a really great way to be able to look up services. Okay, and again, this is a step towards cattle containers instead of pet containers. But it's not the whole way to ants. We need service discovery, but there's a whole lot more there. And again, the ultimate goal is ants, not cattle. All right, so we've researched that. That's right on the cusp of what we're going to be doing. And now the broader roadmap, user management. I went crazy with meme generator. The adoption of new components. Okay, we built a pyramid, now we want to build a ship. We need different components to do that. We need better telemetry. We need scheduling. Right? We need to know where to put things and why they're going there and when to stop them and move them somewhere else. I heard somebody call an AV deployment a Phoenix deployment. I thought it was about the funniest thing I ever heard. So I'm kind of proud of that meme. Yeah, so we need to be able to do AV deployments, all right? I'm doing this right now with our infrastructure, which is all of 1 load balancer and 2 machines. So what happens when we deploy? I bring up 2 new machines. I run Chef, it pulls things out of our registry, does all the things, and poof, it just works. So now what I need to do is pull out Chef and put in Stack Engine Controller. That's on my plate for next week. Yes! I'm really excited about that. Not because I want to get rid of Chef, but just because I want to use the Stack Engine Controller for more stuff. All right, so Stack Engine is the stuff. It'll get easier to dream with Stack Engine because you'll be able to put all these things together. All right, and so now we are to the live product demo, assuming that Al Gore and his gremlins are willing. I think we worked all that out earlier. Thank you for your time. We'll appreciate your comments afterwards. We'll take questions when Mike is done. Actually, I'll take questions now while Mike is getting set up.
All right, cool. Any questions so far for Boyd? There is one.
Yes, sir.
So, you're actually monitoring all the Docker, all the containers and stuff. At what level are you actually grabbing the data? Is it from C groups and namespaces and other things?
Okay. So the question is, you're monitoring. Where are you grabbing the data from? C groups, from namespaces, etc. Actually, right now, all we're doing is monitoring host data, not container data. We need to be monitoring that. And I would love you to tell me why I would want to look in both namespaces and in C groups later this evening. That would be really awesome to know.
Absolutely. And the other thing I have is, are you using any kind of orchestration engine for some of the things there?
For your policy.
Okay, right. So I'm going to repeat the question. So are we using any kind of orchestration engine yet? Yes, it's right here. okay? So we need service discovery before we can do orchestration, right? So we're on the cusp of that. We're trying to decide right now whether we're going to look at integrating Kubernetes, Mesos, Fleet maybe, those sorts of things. Docker is supposed to create an API for the new Docker machine. I think it's Docker machine. They just released 3 of them. So we may integrate with those things. We may write our own. We may do all of those. So we're still trying to figure out what that is. If you get into the beta and you have strong opinions, and we're going to listen to you, okay? So we're looking at what the market wants. If somebody's like, I want Kubernetes, we're going to be like, okay, well, Kubernetes is probably the thing we should do next because we're a business and we want to make money. So we're still working our way towards that.
So I'm Mike from stackengine. I've been in front of some of you before. I know anybody running stackengine right now in your environment? Anybody here at all? Nobody. Okay. I know some people in the group are in the beta. If you are interested in being part of the beta, see me, Mike at stackengine.com. Pretty easy email. We're at beta 2. We released that yesterday. What I'm showing you is that product today. We're still evolving the product. So again, feedback on what you guys want and how you want this thing to work is very important at this point. So what I've done is the way we're set up is we have a leader, we have a couple followers, and then we have a bunch of clients. Those clients are your hosts. Right now I have 8 total hosts within my mesh. And my mesh is pretty much all the hosts wherever they are. They could be in a bunch of clouds, they could be in VMware, could be on your laptop. As long as those hosts can communicate back in, we see it, right? So someone was asking how we're deployed. Well, we're deployed, you take our binary, you install it on your host, on your Linux host, typically Ubuntu, CentOS, whatever. And we just run right alongside the Docker daemon. And we communicate with the Docker daemon, and we know information about the host, we know information about the containers and the images that are on that host. So all of that information is contained in the dashboard here. If you're running on Core OS, anybody using Core OS here? Then you run us as a container, because then we have the requisite libraries and all within the container that we need to run. Still just shows up as a running host. Becomes fairly, benign as to, it doesn't matter whether it's a CentOS host or an Ubuntu host or whatever. It appears as a host. So the dashboard has, right now I know I have 162 running containers. That's an important thing, right? If some of those containers aren't running and should be running, or I need to scale, well, I can easily do that today. And again, as Boyd said, our orchestration is me manually doing this, but we're building the pieces to do the service discovery and the scheduling to be able to do this automatically. Again, we have the ability through our search screen to search for, whatever I might be looking for. I might be looking for Redis. I can easily search for that, and I'll find every place that there's Redis something. It could be a container, it could be an image, whatever. So if I'm trying to track one of those ants, find that needle in the haystack, if you will, I can easily search my entire environment. And some people, today, the people we're talking to, they may have a dozen hosts. Some of our largest customers or people we're talking to maybe have 100, but they're telling me they're going to go to 1,000 pretty soon, 1,000 hosts. And that means, 10,000 containers? So that becomes a pretty onerous thing to keep control of. So search is a very powerful thing. Boyd mentioned, you can see the information about the hosts in your environment. You can get a feeling of, okay, where might I want to deploy? All these guys are running, fairly low, 10% or less in CPU utilization, memory utilization. But it gives me an idea of what the health is of my environment. The coolest thing, though, from a production standpoint, is not our documentation. And the documentation's right there, is this concept called components. So components are a cool thing. And I've got a video out on YouTube where I take a component and I launch it as a Docker container. What I've done here is I've created a standard component for each of my service my microservices, if you will, within my architecture. You know, there might be a MySQL piece or like Lloyd was saying, a Redis piece, whatever. The cool thing is when you create a component, you're saying take this specific image and create a component. What that means for me as an operations guy is I can go over and I can select the Redis component. Let's see, do I have one here? Yeah. I say run, right? Cool. I just pick it and run it. I give it a name. I give it a name called, I just call it test 2. Keep it simple, dash Redis. And here's a cool thing. There's a lot of products out there today, but not a lot of products could actually launch over multiple hosts. So I can pick which hosts I want. I want to put it on 23, and I want to put it on 22. And on each of those, I want 2 containers on 2 hosts. So I'm going to put 4 total containers out, but I'm going to do that. I'm going to restrict their memory to 512 meg, and I can do a whole bunch of other stuff. And scroll down here, and I hit go. And the beauty is, stackengine is doing what's required behind the scenes to make all the magic happen, and putting it out on those hosts. You don't have to know and understand Docker, do this, Docker do that, be at the command line. So what this means again is for operations folks is that it's a clean interface and an easy way to launch things, very, very easily.
So how are you linking other containers?
How are we seeing them?
How are you linking other, for example, if I have a dependency with a different container, so how are you linking those multiple containers?
You want to answer that?
When you say link, you need a Docker link?
Yeah.
So right now, we're not. So we would expect we would expect the application inside the container to handle that, right? Which is brittle. So that's where, again, service discovery is going to help us.
If I rely on my application now, I'm completely swaying away from microservices architecture. Now, I'm kind of messing up with my code, internal code, so that would take off the advantage of containers, right?
It would take one of them away, yes, absolutely. And again, that's why service discovery is the thing we're looking at doing next, because service discovery is the first thing. Because then your application just needs to know, I need to go look for something that's tagged this way. And when it finds it, it can connect to it. So now you don't have that brittleness of the code having to know exactly what to look for anymore. So that's a step in the right direction, but not the final step.
So again, as Boyd said, we are adding service discovery on top of this, then we're adding scheduling and that automation piece, so you can set it and forget it. There's a piece that is not showing here, it's called models. And models, if you take these components, orchestrates those components, and now I can spin up a host in your particular cloud that you use. And I can say automatically if something happens or at a certain time of the day, I want to spin up some extra capacity, spin up extra containers. So the building blocks are getting there. The other cool thing that I like is images. You think containers get crazy about losing them and where they are and all, but you can have all these images everywhere. And the thing about images, I don't know if you know this, but an image is sort of a composite of a bunch of layers of the changes that you've made over time to that code, right? So this I thought was really cool. Let me see here. I've got the I'll bring up the stackengine image that's sitting out on one of the hosts, and we can see all the diffs here and the timeline. So it's family history, if you will, is clearly in front of us, and we know exactly what we've got. The other cool thing is that sometimes, I don't know if this one has it, they fork, right? And so you'll be able to see forks and changes through time visually in this type of view, where then I can I can hover over. Sorry about the zoom level. It looks better on a big monitor. But I can hover over a particular image layer and see the metadata around that. So that is something that we're trying to do. So again, because we feel like these things are just going to become a crazy problem with just sheer numbers. This type of visualization is important.
So
Question?
what does the size of the circle represent?
Size of the circle is basically the size of that particular diff in the build.
Because it says it's size 0. And
The
it's
size of there's two circles actually. There's a light circle, that's the size of the entire image, and then there's the solid circle, that's the size of that layer.
okay.
Make sense?
Yep.
What is it? Yes, sir.
So how do you tie that into your topology engine? There's certain image layers that can't go into China or Germany, or you get booted out of the country.
Well, again, go back to the idea of components. The components would allow you to say, hey, I only want you to use this component, and through tagging and basically a component would only be used for this particular purpose. Our parlance of a component, what I showed you earlier. Does that make sense?
From a system administrator perspective, yes, but from a business risk perspective, that stuff changes dynamically even after I've deployed it, and I have to pull those when I'm under a court order, for example. How do I determine what layers are where in the geography?
I think I'd love for you to participate in the beta. Those are great business questions that we could help you figure out. That's why we're in beta. We're looking for the input of what people actually want to do with this thing. And it's only through real world cases such as this that we're going to be able to understand the dynamics of that. Anybody else? You had a question?
So what are components? Are they just Docker images?
Oh, let me go back to that concept. So within StackEngine, components are Docker images, registries, could be Rackspace hosts, Rackspace Cloud, could be Amazon, AWS, could be VMware. They're the building blocks, the things that you set and say, this is my standard component for my Redis server, right? Or this is my standard component for where I pull my latest images off my private registry. All those are components. And then what we'll do is we'll model those components and orchestrate them. Modeling is not exposed yet. It's built into the architecture, but the modeling engine is not built at this point in time. But components are your building blocks. So they're like the Lego blocks that Boyd was talking about. And a component is a specific term used by StackEngine to describe those different types of things. And as we build it out, there'll just be more tabs across the top of different types of components. And I suspect we'll be able to have you build your own component, right? You'll be able to describe something that's very unique to your environment that's, wouldn't sell to 80% of the market out there, but it might be specific to you. So you may have some components that you build that are specific. And again, all this is built on a REST API that's accessible today. It's not documented. Boyd's got to go document it.
I have Shane.
But the API is probably how a lot of people are going to make this thing work. Okay, but it's there today through our controller. And that's pretty much the demo. Any questions?
I'd like to say one more thing about components. A component is essentially an abstraction of a service. That service could be a Docker container, which is what we're all kind of thinking about because we're here, right? It could also be a Rocket container. Okay? But the idea is that the interface to the component is always the same. So if we can if you want to start an AWS instance, an M3, small, say, you just hit run and you get one. Okay? And you'll get a dialog box specific to that you put things in. So what we're trying to do is we're trying to abstract any service that you would want to consume into a common interface so that you can manage things more smoothly and more easily. Now in a UI, that's all great, slick, and you get lots of nice buttons and lots of nice columns and lots of nice colors. The real power in that comes in an API, right? Where you can reason about the API quickly and you can wrap out a lot of code that's going to do a lot of cool stuff in a hurry because you have a common interface to all of your objects, all of your components, as we call it. Yes, sir?
How do you, so that components, how do you handle Docker components? How do you handle the tags? If you have do you support the tag? Is it always assume?
Will you click edit on one of those, Mike? Yeah. And then click here. This one, the lower one, is easier to understand, for me anyway. So here you're going to have your username and your image name, and then the image tag. So that's how you would pull a specific tag. I think you were asking me the reverse question of how would you tag a thing?
No, I think so. So I guess if you have a multiple tags for that particular MySQL images, that means you have a multiple components.
Okay.
I mean, that's the question. Do you consider, so when you build the MySQL images, right, the daily, because it's a MySQL, but if it's my component I'm developing today, my images will be tagged multiple times a day, right?
So you're sort of making the 10 deploys a day argument, right? You say, like, you take MySQL, you're just saying, I'm a developer, and I'm releasing something to production 10 times a day, which essentially means that tag is moving 10 times a day.
So
What
that
does
means, I mean, I'm just wondering, like, how do you handle that situation with a component? Are you, like, each delivery will be with each component, or?
Okay, so now I'm taking you to mean, and correct me if I'm wrong,
Sure.
that you got a really clunky UI for a situation like that. Is that fair? Yeah. And I would agree with you. But at the point when you're deploying that quickly, anything that you're going to point and click on is clunky. What you need is something automated against the API at that point.
Right.
So at that point, you would automate, as part of the build and deploy, the creation of the component and the management of that component.
I'm just trying to understand the component per tag. So say if I have say one product name, say my ad, I have 100 tags. They're becoming 100 different components if I'm keeping those 100 different versions of it.
Today, the answer is yes,
Okay.
because our thinking about that is as I described. You would be releasing those at some sort of cadence, right? And so we would only really care about probably the last 3 of those components, and the rest of them are just cruft that maybe you garbage collect at some point.
Yeah, depending on your release cycle.
Right.
Depending on if you are really agile, and if you deliver it every day. Then
That's exactly right. And so at that point, what I would say is the UI is something you have to eschew for a stronger form of automation, like hitting the API directly. So, and it could be that this component ID that we have, again, we're in beta, is getting in the way and we need something else. So, again, as Mike said, come join us in the beta. Let's get this figured out.
Any other questions? Paul?
Scheduling. So right now you're doing manual placements.
Yes.
Are you waiting to solve the service discovery problem before you do scheduling?
Yeah, because it's a, we built the architecture, we built the ability to deploy to the hosts and create a mesh, create a communications between it, moved up to control, so we can manually control. Now we're putting in some of the building blocks, the components, service discovery then, and then schedule. And we're not talking months here. This is pretty quick. Karthik's on board, so we're going to get this done, right, Karthik?
Yeah.
Yes.
Everything y'all are talking about, Karthik is going to do. So just ask Karthik. He started on Monday. He knows everything already.
He's got it.
Good work, guys.
Anyway.
Yeah, Paul, we see service discovery as a prerequisite to everything else, essentially, because if the services can't find each other and we don't know the state of a service, like for instance, you start a container and it goes away. That's supposed to happen. They're ants. Well, the service discovery mechanism should know that it went away. How does that happen? Absence is always the most difficult thing to track, right? Did it go away? Is it just paused? Was there a failure event? Did it just shut itself down cleanly? I mean, those sorts of things are all going to go into something like that. So we need service discovery to start making more. We need that as another dimension of that bin and the bin packing problem.
But all good stuff. What do you guys think?
Interested
Anyway.
in beta.
So again,
Great. It was worth buying a pizza then, right there.
just shoot me an email, mike@stackengine.com if you have an interest. I appreciate that.
Thanks for your time.